Welcome to this course on manufacturing process and control system. Manufacturing is the backbone of industrial development. It is the process of converting raw materials into useful products by applying physical, chemical, and mechanical methods. Alongside manufacturing, control systems play a vital role in ensuring that these processes are efficient, precise, and reliable. In this course, we will explore two interconnected areas: the processes and equipment used in manufacturing, and the control systems that regulate and optimize these processes. The course is divided into two modules. Module 1, Manufacturing Processes and Equipment. Module 2, Control Systems and their applications in manufacturing. By the end of this course, you will have a solid understanding of how products are made, shaped, and assembled, as well as how control systems govern these operations to achieve stability, accuracy, and efficiency. Let us begin with Module 1. Module 1, Manufacturing Processes and Equipment. 1.1 Forming and Shaping Processes. Forming and shaping processes involve changing the geometry of a material without adding or removing material. Instead, mechanical forces are applied to plastically deform the material into the desired shape. Examples include forging, rolling, extrusion, and sheet metal forming. Forging uses compressive forces, often with a hammer or press, to shape heated metal. Rolling reduces the thickness of metal by passing it between rollers. Extrusion forces material through a die to produce long shapes such as rods, pipes, and channels. Drawing pulls material through a die, reducing its cross-section. These processes are widely used in making automobile parts, pipes, and structural components. 1.2 Material removal processes. Unlike forming, material removal processes involve cutting away excess material to obtain the desired shape. Examples include turning, drilling, milling, grinding, and shaping. Turning, using a lathe to remove material from a rotating workpiece. Milling, removing material with a rotating cutting tool that moves across the workpiece. Drilling, creating holes using a drill bit. Grinding, producing fine finishes and precise dimensions with an abrasive wheel. Material removal processes are fundamental for producing precision components. 1.3 Cutting tools and machinery. Cutting tools play a critical role in material removal. They must be hard, wear-resistant, and able to withstand high temperatures. Common tool materials include high-speed steel, carbide, and ceramics. Machinery such as lathes, milling machines, drilling machines, and grinders are designed to hold both the workpiece and tool in proper alignment, ensuring accuracy and repeatability. 1.4 Sheet metal forming. Sheet metal forming focuses on shaping thin sheets of metal into functional parts. Processes include bending, producing angles or curves. Deep drawing, shaping flat sheets into hollow forms such as cans. Stretch forming, stretching metal to achieve curved surfaces. These techniques are widely applied in automotive, aerospace, and household appliance industries. 1.5 Forming and shaping of plastics and composite materials. Modern manufacturing also uses plastics and composites, which offer lightweight and corrosion-resistant alternatives to metals. Processes include injection molding. Molten plastic is injected into a mold to form complex shapes. Blow molding, used to produce hollow objects like bottles. Compression molding, preheated plastic is pressed into a mold cavity. Composite forming involves layering fibers with resins to form lightweight, strong structures. 1.6 Joining processes. Joining processes combine two or more parts into a single assembly. Common methods include welding, fusion of materials using heat or pressure. Brazing and soldering, using filler metals at lower temperatures than welding. Adhesive bonding, using glues or resins. Mechanical fastening, bolts, rivets, and screws. Solid-state welding processes, such as friction welding and ultrasonic welding, join materials without melting, providing high-quality joints with minimal defects. 1.7 Metal casting. Casting involves pouring molten metal into a mold, where it solidifies into the desired shape. Casting methods include sand casting, using sand molds, suitable for large and complex shapes. Die casting, forcing molten metal into steel molds under high pressure. Investment casting, using wax patterns coated with ceramic, ideal for precision parts. Casting is crucial for producing engine blocks, machine frames, and complex geometries. 1.8 Powder metallurgy. Powder metallurgy produces components by compacting metal powders and then sintering them at high temperatures. Advantages include precise control over composition and properties, ability to produce complex shapes with minimal waste, suitability for mass production. Applications include gears, bearings, and cutting tools. 1.9 Surface treatment. Surface treatments enhance properties such as hardness, wear resistance, and corrosion protection. Examples include heat treatment, processes such as quenching and tempering, coating, electroplating, painting, and anodizing, surface hardening, carbizing and nitriding. Surface treatments extend the lifespan and performance of components. 1.10 Non-conventional machining processes. Non-conventional methods are used when traditional machining is difficult or impossible. Examples include electrical discharge machining, EDM, material removed by sparks between an electrode and workpiece. Laser beam machining, using concentrated light energy to cut or engrave. Water jet cutting, high-pressure water stream, sometimes mixed with abrasives. Ultrasonic machining, vibrations of an abrasive slurry to shape hard materials. These methods are essential for hard, brittle, or heat-sensitive materials. 1.11 Jigs and fixtures. Jigs and fixtures are special devices that hold, support, and locate workpieces during manufacturing. Jigs guide the tool, ensuring precision. Fixtures hold the workpiece in place securely. They reduce human error, increase efficiency, and ensure consistency in mass production.